This is Mr. Hanna. Welcome to What the Format. Today we're going to start to go over solving quadratics. Now, you can see there's 5 methods, so it's a really big topic. It's going to take a few videos. Some of these are going to be easier to digest than others. Factoring, one of the number one things to do with quadratics, and for some reason this day and age that seems to be a real problem for a lot of students. In fact, when you are getting into algebra, this is usually where okay, I've survived linear equations, I'm making it through, and then quadratics hit and it's all over. As you can see, if you look at some of my other videos, like with polynomials, you'll notice that the number of steps in problems start to really magnify. There's a lot of steps. The steps individually aren't necessarily hard, like adding polynomials, doing a 7 plus 9 or 5 minus 3. Those are easy, but when there's lots of them, it's real easy to miss one thing and make a mistake. Quadratics just take it to another level. Instead of having 2 terms, linear equation, you know your mx plus b. Now we've got the squared term, the x term, and a number term. Okay. Now this is in standard form. X squared minus 5x minus 24, which when we're factoring, that's what we'll be in, is in standard form. So we're going to go over factoring today, but notice there's also graphing. There's the square root method. There's completing the square, and then there's finally the quadratic formula, which is that monstrous thing x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you're not mind blown by now, yeah, that's what it is. So hopefully you can start to make sense of that. Now these are interesting. They use completing the square to solve quadratics, which I find interesting because that's how the quadratic formula is derived, is by completing the square on a generic ax squared plus bx plus c. I only used completing the square when I was a student for going from standard form to vertex form, but they now oftentimes say use completing the square to solve. So we'll cover that, and I'll show you how completing the square uses the quadratic formula. And then when you get to a situation, if you're given a choice, you can use whatever method that you feel is appropriate. Now, please notice though that at some point quadratic formula is necessary because it works on all quadratics, whereas factoring doesn't work on the prime quadratics. What do you mean prime, Mr. Hanna? Well, factor 7. You can't. 7 is a prime number. It only factors to 1 times 7. Okay, some quadratics are like that. They can't factor. They can't break down into binomials like we're going to do, like I'm going to show you an example of here. But again, notice the 5 methods. Graphing. How does it work with the graphing? Well, the solutions of a quadratic are where it crosses the x-axis. Those are your solutions. That's what you're looking for. Okay, they can call those the x-intercepts because that's where you're crossing the x-axis. They also call it your solutions. 2 other names for it are roots and zeros. And if you look that up, sometimes you'll see that. And a lot of students struggle with that because now there's 4 different ways to ask the question. As they solve it, find the x-intercepts, find the roots, find the zeros, and students will forget that they mean the same thing, and so they'll get in trouble. Notice that most quadratics, or a lot of them, have 2 roots. Okay, I won't say most, but a lot. They can also have 1 root. It could touch the x-axis once, or it might not even touch it. So then you don't have any real solutions. That's a possibility. That's when we would get into imaginary numbers, but that's more on the algebra 2 level. So, well, you can see with my shirt, imaginary numbers. It's all fun and games until somebody loses an eye. This is an imaginary number, square root of a negative number. Well, we get that because we have squares, and when the inverse of a square is a square root. So you could get imaginary numbers as some of your answers, but again, that's going to be an algebra 2 thing. So in algebra 1, though, you want to know that there's either 2, 1, or 0 solutions to quadratics, or I should say 2 real solutions, 1 real solution, or no real solutions. Notice we're qualifying that with the real after it. Now, so we're going to go over factoring a little bit. That's what I want to kind of focus on. So here we have x squared minus 5x minus 24. You're looking at that. Where do I even start? Good question. First, you need to know what this is going to break down to. When trinomials factor, okay, they factor into 2 binomials. Okay, much like 6, we can factor that down into 2 times 3, 2 numbers. Okay, we're looking for 2 numbers. Now they're going to be in binomial form, so it doesn't look like 2 numbers, but that's what it is. It's this binomial times that one. So basically, if you look at my multiplying and the foiling, we're reverse foiling. So foiling is going forward. We multiply them to get the 2 binomials to our trinomial, but now we're going to reverse that and go backwards, okay? So since 2 times 3 is 6, we can factor 6 to 2 times 3. But you're looking at this and your brain's thinking, holy cow, there's infinite possibilities. What do I even do? I don't even know where to start. Always start with your C, okay? Look at the number, it's 24. What you want to do is you want to factor pair 24. So the factor pairs of 24 are 1 and 24. You always want to start with 1 in the number. Now we go down. 2 times 12 is 24, so we go 2 and 12. 3 times 8 is 24, so we go 3 and 8. And then 4 times 6 is 24. Now you'll notice that the numbers pinch, and then when we get to 5 times 5 is 25, so it's not a factor pair of 24. So there's 1, 2, 3, 4 factor pairs of 24. So whatever your C is, that's what you want to do, okay? So for factoring, you want to factor pair your C. C is always the back number, okay? Notice I labeled these. A was 1 on this one, B is -5, C is -24. For the record, this is how you factor quadratics when A is equal to 1, okay? When A is not equal to 1, there's some extra steps that we have to add in there to do that, okay? It's still going to involve some factor pairs, but there's a couple steps that have to be added to the process to make it work. So since A is 1, I can go right to the C and factor pair it, okay? So factor pair C, okay? This is when A is equal to 1. Now, you want to look at the sign of the C. If it's a positive, you're going to add the factor pairs to get the middle number, B. If it's negative, you're going to subtract. Since this is a minus 24, we're going to subtract. So 1 minus 24, or 24 minus 1, you're going to get plus or minus 23. 2 minus 12, 12 minus 2, plus or minus 10. This will give me plus or minus 5, plus or minus 2. Now, please notice that the number is what matters. It can be positive or negative, but you need the number. We need a -5. Okay, now what do? -5, it's not 8 minus 3, it's what? 3 minus 8. So we want a plus 3 and we want a minus 8. So you'll notice that positive 3 times -8, there's your -24. And when we add these, -8 plus 3 is your -5. That's what we're doing when we factor. Now, to get x squared, you just need to have x times x. And when A is 1, that's what your binomials will always be. X plus or minus some number, x plus or minus some number. And guess what? You're done. That's it. That's factored. Okay, one more example so you can see it. I'll do it with a plus now. So we're going to do x squared. Let's see, let's do plus 10x plus 21. So I'm going to look at my A. It's 1. That's the first clue. C is 21, so I can just go and factor that. Well, 21 factors 2, 1 times 21, and 3 times 7. Now, you'll notice some numbers are easier to factor than others, okay? 24 had 4 factor pairs. 21 only has 2. Now, I'm looking for the sum of those. So 1 plus 21, I'm either going to get a plus or minus 22, or I'm going to get a plus or minus 10 there, okay, with the 3 and the 7. My middle number is 10, so I want the 3 and the 7. So we'll come up here and set it up. We want 2 binomials. Since it's x squared, we want x and x. Okay, now to get a plus 10, I need a plus 3 and a plus 7. Yes? And all you have to do is check it real quick. X times x, that is your x squared. I've got a 3x and a 7x. Added together is your 10x, and 3 times 7 is 21. So I have factored it. Now, if you break it down into these steps, it's not too bad. Of course, sometimes your back number can get rather large and have lots of factor pairs, and that's where I see a lot of students struggle. They never really memorize their multiplications, so factoring when you can't multiply becomes quite difficult. It's like 36, there's lots of factor pairs of 36. Some students remember 6 times 6, some remember 4 times 9, but they'll forget the others, like 3 times 12. They'll forget 1 times 36. You can see where that would become a problem. And I'm going really fast, so maybe even I forgot one there. But that's where if you write it out, you're like, wait, there's one other. Yep, 2 times 18. See, not just 3 times 12, 2 times 18. So I had to slow it down in my head and actually think through it. Why? I don't do 2 times 18 is 36 as often as I do 4 times 9 or 6 times 6. Neither do you. And what we use a lot tends to stay in our brains. What we don't use a lot tends to kind of go away. And then here comes factoring, and you have to bring all the factor pairs of a number back. And it's like, well, I haven't seen that factor pair in months. My brain didn't remember it. And if that's the one they pick, well, then you're stuck, because that's only one combination of pairs works here. Okay. Now, what happens if none of these work? What if I try my factor pairs and I can't get to the middle number? Well, then this is prime and you can't factor it. So that's something else you're going to remember, and it needs to be prime. What's an example of that? Okay, well, if I just did x squared plus x plus 7, what are my factors of 7? Well, it's just 1 and 7. 1 plus 7 add to what? I get plus or minus 8. Yes? There's no 8 in the middle. I can't break that up. Okay? I can't put two numbers that multiply to 7 and add to the 1 in the middle, so this is prime. Prime means not that you can't factor. You can't write it as a product of two binomials. This is when you have your no real solutions. Okay, is when it's prime. These are your two solutions. Now, we'll get over solving it. That's the factoring part of it. Now, to solve a quadratic, you need to set it equal to 0. Okay, and if this is going to be equal to 0, we use the zero product property. If I have a times b is equal to 0, I know that a or b have to equal 0. Okay, so if I have a times b equals 0, either a is 0 or b is 0. Okay, so to solve these, we set these equal to 0 like this. And that's how you solve all quadratics. You need to set them equal to 0. And then since there's two possible numbers, we set each one equal to 0 and solve. So x plus 3 equals 0. Well, when you subtract the 3 from both sides to solve, you get x equals negative 3. Here, x minus 8 equals 0. So now we're going to add the 8 to both sides, and you're going to get x equals 8. Now, if you're paying attention and see a pattern, you'll notice that because you're solving, you do reverse PEMDAS, and you do the opposite of the number, a plus 3 becomes a minus 3, and a minus 8 becomes a plus 8, and that's the pattern. Your factors are always the opposite sign of your zeros or solutions, your x-intercepts. So opposite plus 3 would be a negative 3 again. Opposite plus 7 would be a negative 7. So negative 3, negative 7, those would be the solutions to that quadratic. The solutions are always the opposite, okay? But remember, this is called the zero product property. When you multiply to get 0, you have to have one of the numbers you multiply by be 0. Now, when there's two or more numbers, any of them can be 0. I only need one of them to be 0. Multiple of them could still be 0. So like if I had A, B, C, D, A and C could be 0, but at least one of them has to be 0. That's what the zero product property says, okay? So then we just, once we factor it, we set each factor equal to 0 and solve them separately. Now, once you practice this and get used to it, you'll be, like I am now, you'll just be able to see that and go, oh, that's negative 3, that's plus 8, because you'll know that the zeros are the opposite of your factors. But this is a lot, and this is just the beginning of solving quadratics. So you're going to want to really practice your factoring. Also, this is factoring only when a equals 1. Remember, when a doesn't equal 1, there's more steps involved. So this is the time where you need to take a deep breath and start really sorting this out in your head. You might need to write it out, rewatch the video a few times. Not all at once, but you might need to break it down and say, watch the video one day a week until you kind of see the pattern, start to see what's going on. If you have a teacher or tutor, ask them for a little help and some guidance. Solidify these steps in your head. And fair warning, it just gets bigger and bigger from here. So this is the part where you really need to be paying close attention to what I'm doing and why. Hopefully I've explained everything clearly and you can see each step. And then, like I said, if you have to rewatch the video multiple times, please do so. This is solving quadratics using factoring when a equals 1. Okay. Primarily, what I would do is maybe focus on the factoring first, then go back with the solving. And if you look at a lot of your classes, that's what will happen. You'll factor first, then you'll bring in the solving. I wanted to cover both in the same video just because now you have the whole thing there. And in a video, since you can go back and rewind, you can go back and do the factoring part first and pause, get all the factoring down, then you can come back to the solving if you would like. Anyway, this has been Mr. Hanna. Thank you for watching What the Format. Happy mathing.